Okay, in organic chemistry, always coupled problems are asked. Okay, so always whenever there is a question, so many concepts are coupled together. So you have to answer that question. So coupled questions in pericyclic reaction. Some popular coupled questions that asked in pericyclic reaction. First one is the Wittig reaction. Wittig reaction. I think you studied about Wittig reaction in your PG classes. Okay. All the detailed aspects of Wittig reaction we will study in the named reaction section. But now for pericyclic reaction, I will give a brief introduction about Wittig reaction. Detailed aspects of Wittig reaction that we will study later in the named reaction section. So what is Wittig reaction? Wittig reaction means a carbonyl compound. A carbonyl compound on reaction with a phosphonium ylide. Phosphonium ylide to form a higher alkene. Higher alkene means alkene having more number of carbon atoms. This is the very famous Wittig reaction and a useful reaction in synthetic organic chemistry. Okay, so basically a carbonyl compound on reaction with the phosphonium ylide, a higher alkene is your product. Higher alkene. For example, this is a carbonyl compound. On reaction with the phosphonium ylide, CH2 double bond PPH3. CH2 double bond PPH3. CH2 double bond PPH3 is called as ylene. This is called ylene. Y-L-E-N-E. CH2 double bond PPH3 is called as ylene. When this double bond is shifted towards this carbon, that is called as ylide. So basically the form of ylide is CH2 minus PPH3 plus ylene. Y-L-I-D-E. Ylide. CH2 minus PPH phosphonium. Phosphorus containing positive charge, neighboring carbon containing negative charges. And then when two opposite charges are adjacent like this is called as an ylide. Okay, sometimes in ylene form also question given, but this is the ylide, phosphonium ylide. So a carbonyl compound plus phosphonium ylide. What is the type of reaction? What is the type of reaction? This electron attack the carbonyl carbon, which is an electrophilic carbon. This pi bond shift towards here, so you will get O minus. This is attached to CH2 and that CH2 contain PPH3 plus. PPH3 plus. That is the first step. In the next step, this O minus will attack the phosphorus because phosphorus contain vacant d orbital. Okay. So in the next step you will get O carbon CH2 PPH3. So a cyclic intermediate is formed. Cyclic intermediate. Then in the next step PPH3 double bond O minus PPH3 double bond O. Phosphonium oxide PPH3O is eliminated and you will get the product double bond CH2. You will get the product double bond CH2. This is called as Wittig reaction. So a carbonyl compound on reaction with the phosphonium ylide. This phosphonium ylide will attack at the carbonyl carbon. An intermediate formed. This negative charge attack the vacant d orbital of phosphorus to form a cyclic intermediate. After that, the bond shifting PPH3O is eliminated. Here a double bond CH2. So the C double bond O is replaced by double bond CH2. See, double bond O is replaced by that group, double bond CH2. This type of reaction is called as Wittig reaction. But in your exam, a short form is there, short form. You can easily write the product. Short form. How you can easily write the product. For example, a carbonyl compound is given. Plus an ylide is given. Ylide PPCH2 minus PPH3 plus, same reactant. How you can easily write the product? This oxygen and PPH3 minus PPH3 double bond O. PPH3 double bond O is eliminated. Then there is only one CH2 that is attached here. So this is the general short form of Wittig reaction. Okay. So Wittig reaction is basically a carbonyl compound on reaction with a phosphonium ylide. Just cut and paste. PPH3 is cut, then CH2 pasted here. Okay, double bond O and PPH3 cut to form PPH3 double bond O, CH2 is pasted there. Okay, one more example. You can easily write the product. of a Wittig reaction. For example, this is a carbonyl compound. Okay, on reaction with CH2 PPH3 minus plus. You know, definitely this is Wittig reaction. Why? A carbonyl compound and a phosphonium ylide. How you can write the product? Cut and paste. O and PPH3 minus double bond O PPH3. PPH3 O double bond O is eliminated. This is eliminated. Then this CH2 pasted. Double bond CH2. You can easily write the product of Wittig reaction. Another example. A carbonyl compound plus RCH minus PPH3 plus. RCH minus PPH3 plus. What type of reaction? Carbonyl compound, phosphonium ylide. How you can write the product? Cut and paste. Double bond O, PPH3. PPH3 and O, PPH3 O is eliminated. Double bond O, PPH3. Then what is the product? Paste the remaining part here. The ring, here double bond is there. So CH, that is the product. So you can easily write the product of a Wittig reaction. So always Wittig reaction, a carbonyl compound plus a phosphonium ylide gives a higher alkene. Detailed aspects we will study in the named reaction section. Then one more thing, write a note. Also. This is a phosphonium ylide, CH minus, PPH3 plus. Here a group G is present. A group G, that may be an R group, CH3 group or NH2 or CH or CHO, OH, any group. A group G is present. Okay, if G is an electron withdrawing group. G is an electron withdrawing group. What are the common electron withdrawing group? CHO is an electron withdrawing group. COOH is an electron withdrawing group. Okay, so this type of electron withdrawing groups are COOR. Ester is also electron withdrawing group. COOR. So if your the G group is an electron withdrawing group, EWG. the product formed is an E-alkene. Very, very, very important. The product formed is an E-alkene. At the same time, if your group G is an electron donating groups like OH, CH3, NH2, etc. Electron donating groups like OH, CH3, NH2, etc. The product formed is an Z-alkene. Product formed is an Z-alkene is the major product. So give a star mark. Very, very, very important. So your phosphonium ylide containing a group G. Suppose your group is an electron withdrawing group. Group is an electron withdrawing group. The product formed is E. E means same prior group on opposite side. Z means same prior group on same side. Same prior group on same side. Same prior group on opposite side. E-alkene. Okay. So please write an example. G is an electron withdrawing group. G is an electron withdrawing group, E-alkene. Okay. C double bond O, pH H on reaction with CHO, CH minus, PPH3 plus. What type of reaction is this? Definitely Wittig reaction. How you can identify a carbonyl compound and a phosphonium ylide? A carbonyl compound and a phosphonium ylide, definitely that is a Wittig reaction. You can write the product easily. Cut double bond O and PPH3 to form PPH3 phosphorus oxide, PPH3 double bond O plus. What is the next product? That is my question. What is the next product? Here pH C, here a hydrogen is there, double bond. In the phosphonium ylide, a group is there and this group is an electron withdrawing group. This group is an electron withdrawing group. You know, when an electron withdrawing group is present in the ylide, the product formed is an E-alkene. E-alkene means same prior group on opposite side. Same prior group on opposite side. So here there is a carbon is there, carbon. So hydrogen and the hydrogen are opposite, then CH2. So this is an E-alkene. E-alkene. So when you are pasting the CHO here, this hydrogen and the hydrogen are same prior group on opposite side, then CH2. So definitely the product formed is an E-alkene. Okay, so this is a Wittig type reaction. Okay, another example, double bond O, pH H hydrogen plus ylide CH3 CH minus PPH3 plus. What is the type of reaction? Carbonyl compound plus phosphonium ylide, Wittig reaction. Carbonyl compound plus phosphonium ylide, Wittig reaction. So we will get, how you can write the product? Cut. So PPH3O is eliminated. PPH3O is eliminated. Plus, what is the stereochemistry of the product? Here the G group is an electron donating group. Methyl group is electron donating. So the product is Z-alkene. That means pH, here a hydrogen is there, double bond. Here in this carbon a hydrogen and the CH3 is there. In this carbon a hydrogen and the CH3 is there. So hydrogen and the hydrogen same group, then CH3. Same prior, you can compare the hydrogen. Same prior group on same side, Z-alkene. Same prior group on opposite side, E-alkene. Okay. So in the G, if the group G, here G group, CHO is electron withdrawing. Here the group G is electron donating group. Okay. If your G group is an electron donating group, the product formed is an E-alkene. Otherwise it is Z-alkene, otherwise it is an alkene. So that is the stereochemistry of Wittig reaction. So Wittig reaction is basically shown by carbonyl compound and phosphonium ylide. So moving to some coupled question. First one, Wittig reaction and pericyclic reaction, coupled questions. CHO, first condition thermal, second condition CH3 CH double bond PPH3. Okay, first condition thermal condition, second condition CH3 CH double bond or PPH3. What is the reaction? So a conjugated polyene under thermal condition. What is the type of reaction? Electrocyclization. Conjugated polyene under thermal condition. Electrocyclization reaction. Giving number to the carbon 1, 2, 3, 4, 5, 6. 6 pi electrons are involved in the cyclization process. So what is the cyclization process? This pi electron towards there, this towards there. This will make a sigma bond between first and sixth carbon. A sigma bond is formed between first and sixth carbon. So you will get a 6-membered ring. A 6-membered ring is formed. And in that ring giving number 1, 6, 2, 3, 4, 5. Between 1 and 6 a new sigma bond is formed. Between 2 and 3 a pi bond is there. Between 4 and 5 a pi bond is there. At the first carbon there is a CHO, C double bond OH. C double bond OH. So that is the product formed in the first step under thermal condition. Then what is the next reagent? CH3 CH double bond PPH3. Here instead of ylide form, ylene form is given. Ylene undergo resonance to form ylide. This bond shifted towards the second carbon CH2 minus PPH3. So ylene or ylide both are given in the question. And a carbonyl compound and an ylene. A carbonyl compound and an ylene. What is the product? What is the reaction? Wittig reaction. How you can write the product? Cut. So what is the byproduct? Byproduct is O double bond O PPH3. That will be eliminated. And you have to think about the stereochemistry also, because our G group is an electron donating group. So definitely the alkene formed is an Z alkene. The alkene formed is an Z alkene because G group is an electron donating group. So how we can write the alkene? Here a carbon is there. Here a new double bond is formed. Here another carbon. This carbon contains hydrogen. Okay. So since CH3 is electron donating, the alkene formed is Z. That means same prior group on same side. Same prior group on same side means hydrogen and the hydrogen on same side. Here CH3. So hydrogen and the hydrogen on same side. So you will get the product which is an Z alkene. Product which is an Z alkene. That is the product. You will get the product which is an Z alkene. Okay. So this type of coupled questions also you can expect in your exam. Second one. Second question. Here CHO, here CO2R. First condition, photochemical condition. Second condition, CHO, CH double bond PPH3. CHO, CH double bond PPH3. That is the reactant. So how you can write the product? How you can write the product? That is my question. So a conjugated polyene under photochemical condition, definitely electrocyclization. A conjugated polyene under photochemical condition or thermal condition, electrocyclization. Giving number 1, 2, 3, 4, 5, 6 carbons are there. First one towards there. This will make a sigma bond between first and sixth carbon. A new sigma bond is formed between first and sixth carbon. So a 6-membered ring. Here 1 and 6, a new sigma bond is formed. This is 2, 3, 4, 5. So between 2 and 3, a new pi bond is formed. Between 2 and 3, a new pi bond is formed. Between 4 and 5, a new pi bond is formed. Here two groups are there. What is the stereochemistry of that two groups? What is the stereochemistry of that two groups? One group is towards the upside, one group is towards the downward side. So both groups are in opposite side. And how many electrons are involved in the cyclization process? In the cyclization process, 2, 4, 6. 6 electrons. So system is 4n plus 2 system. Condition photochemical. 4n thermal cone. So 4n plus 2 photochemical cone. 4n thermal cone, then 4n plus 2 photochemical cone. Then substituents are opposite. So you can follow the ODC rule. Substituents opposite, rotation disk, no, rotation is cone. So take the next one, OCT. Substituents are opposite, cone rotation, definitely stereochemistry of that two groups is trans to each other. So these two groups are trans to each other. That means the first group is above the plane. First group is above the plane. Then the second group will be below the plane. CO2. So that is the stereochemistry of that two groups. Okay, two groups are on opposite side. Disrotation, definitely stereochemistry of these two groups will be trans to each other. In the next step, an ylene is given, not ylide, ylene is given, but no problem. Ylene or ylide definitely Wittig reaction. PPH3, ylene or ylide Wittig reaction. You can easily write the product. C double bond of cut. So your byproduct is O double bond PPH3 plus. Then what is the stereochemistry of that newly formed alkene? What is the stereochemistry of that newly formed alkene? Your G group is an electron withdrawing group. So the newly formed alkene is an E alkene. So you can write the product. Double bond. Here stereochemistry, one above the plane and the other below the plane. CO2R. Here carbon. Here a new double bond is formed after Wittig reaction. Then since CHO is an electron withdrawing group, E alkene is formed. That means the two newly formed, the two hydrogens are opposite side, and here a CHO is there. So this is the final product. Clear? So a conjugated polyene, two substituents, CHO and CO2 are under photochemical condition and in the presence of a phosphonium, ylene, and phosphonium ylene is given. After that, electrocyclization takes place. Think about the stereochemistry, then Wittig reaction. Think about the stereochemistry. Stereochemistry is very important in organic chemistry. So we studied one more named reaction called the Wittig reaction and its stereochemical aspects. Okay, so Wittig reaction is basically a carbonyl compound and a phosphonium, ylide or ylene. A new alkene is formed. Withdrawing group is there in the ylene, then E alkene, donating group, then Z alkene. Okay, next question. What type of reaction? A doubly alpha beta unsaturated carbonyl compound, H plus, thermal condition, phosphonylide. Okay, so first Nazarov cyclization, then after that Wittig reaction. So this type of coupled question that you can expect in CSIR net exam. Okay, so first Nazarov cyclization followed by Wittig reaction. So what is Nazarov cyclization? The lone pair on oxygen will attack the H plus. So in the first step you will get this become OH plus. Okay, OH plus. Then under thermal condition, cyclization takes place. This pi electron towards there, this towards there. So after cyclization, a 5-membered ring, here a pi bond, here an OH, and here a positive charge. Next step, elimination. Resonance is possible, but both resonance structures are identical. So alpha elimination, this hydrogen will be eliminated, minus H plus. After elimination of hydrogen, you will get OH and double bond, which is an enol. This is an enol. This enol will undergo tautomerism. What is a tautomerism here? So this OH sigma bond will make a pi bond here. This pi bond moves toward this carbon. So the next step, ring double bond O minus. And that minus will catch up the H plus to form the stable neutral product. So a carbonyl compound is formed. Then third reagent, which is a phosphonium ylide, CH3, CH2, CH minus, PPH3 plus, phosphonium ylide. You can easily write the product, cut and paste. Cut. So O double bond PPH3 is the byproduct, and what is the product? So here the G group is an electron donating group, R group is electron donating. So you will get an Z alkene. So how you can write the Z alkene? A 5-membered ring. Here a double bond is there. I think here also a double bond is there. Is it? Double bond. Okay. Is it? So R group is electron donating, so Z alkene is formed. How you can write the Z alkene? Same prior group on same side. So here this is carbon, hydrogen, CH2, CH3. This is Z alkene. How we can say this is an Z alkene? We will study the Ez nomenclature in stereochemistry. Okay, this is an Z alkene because in this carbon, this is the first prior group. Hydrogen having second priority. Higher the atomic number, higher is the priority. So this is the most prior group. In this carbon, two substituents are there. One is this portion and the other is this portion. So this is the most prior because a double bond is present. At the right side portion, a double bond is present. So this is the most prior in this carbon and this is the most prior in this carbon. So same prior group on same side. So that is an Z alkene is formed. So that is a major product formed here. Another important reaction, like Wittig reaction, you can expect in pericyclic reaction is hydrolysis of, this is also coupled reaction, hydrolysis of vinylic ether. This reaction that we will study later, hydrolysis of vinylic ether. So what is vinyl group? CH2 double bond CH. This is the vinyl group. 2 carbon double bond. Okay. Vinyl group. Here an ether. OCH3. So this is a vinylic ether. A carbon-carbon double bond followed by a OCH3 or an OR group. A carbon-carbon double bond followed by an OR group is an example for vinylic ether. Hydrolysis. H plus bar H2O. Hydrolysis of vinylic ether, an important reaction that we will study later. Okay. So oxygen containing lone pair. This lone pair will attack the H plus. So you will get CH2 double bond CH OH plus CH3. Okay, OH plus CH3. In the next step, water is there. Water is H2O. And SN2 type reaction. SN2 attack means backside attack. SN2 reaction is backside attack. The lone pair present on oxygen will attack this carbon this bond is shifted towards that side. Okay, this is a type of SN2 attack or the backside attack. The lone pair on oxygen attack this carbon, and this sigma electrons shifted towards the oxygen atom, and you will get the product CH2 double bond CHOH. CH2 double bond CHOH is the product. Methanol is eliminated. Methanol is eliminated. This is an enol. This is an enol, and this will undergo tautomerism. Tautomerism means the OH sigma bond shifted towards this carbon, this towards this carbon. So this becomes CH2 minus, and catching that H plus also, you will get CH3 CH double bond O. So an aldehyde or a carbonyl compound is formed. An aldehyde or a carbonyl compound is formed. So hydrolysis of vinylic ether H plus bar H2O. In the first step protonation, second step SN2 attack to form an enol which undergo tautomerism to form a carbonyl compound. This type of reaction is called hydrolysis of vinylic ether. Another example. For example, OCH3. This is also an example for a vinylic ether because a carbon-carbon double bond followed by an OR group. H plus bar H2O. Definitely this reaction is hydrolysis of vinylic ether. What happens? This oxygen containing lone pair, that lone pair will attack the H plus. So in the first step you will get double bond OH plus CH3. In the next step, water H2O, the lone pair on water, SN2 or SN2 attack or the backside attack. The lone pair will attack this carbon, this pi electron shifted towards the oxygen, and you will get an enol in the next step. Ring double bond OH. An enol is formed. What happens? Enol is unstable. That will undergo tautomerism. What is a tautomerism? The OH sigma bond make a pi bond here. This move towards that carbon, and finally you will get a carbonyl compound. C double bond. Here minus catch up the H plus. Okay, so a carbonyl compound is formed. So a vinylic ether on hydrolysis in an enol formed which will convert into a carbonyl compound. Another example, example 3. OCH3 H plus bar H2. What type of reaction? Definitely hydrolysis of vinylic ether because a carbon-carbon double bond followed by OR group. This is an example for a vinylic ether. H plus bar H2O. Oxygen containing lone pair that will attack the H plus. So you will get the ring. Here a pi bond, here a pi bond. O CH3 H plus. Next step SN2 attack of water. SN2 attack of water. Oxygen containing lone pair. Backside attack at this carbon and this pi bond shift back to the that sigma electron shift back to the oxygen, and you will get an enol. An enol like this OH. This is an enol that undergo tautomerism. How is a tautomerism? This OH sigma bond make a pi bond here. This will move towards this carbon and this will move towards this carbon. Here extended conjugation is possible because two pi bonds are conjugated. So extended, if extended conjugation is possible, that is the most stable. Extended conjugation is possible because OH sigma bond make a double bond here. So double bond O. Okay. Then this pi electron shifted towards this side. This pi electron on this carbon minus and that H plus that become neutral. So finally you will get an alpha beta unsaturated carbonyl compound. alpha beta unsaturated carbonyl compound. So these are two typical examples of hydrolysis of vinylic ether. A vinylic ether H plus bar H2O. This is also vinylic ether. Here extended conjugation is possible. The enol undergo tautomerism to form carbonyl compound. Here extended conjugation is possible. So the type of reaction that we discussed is some type of typical reaction, Nassarov cyclization, Wittig reaction, carbonyl compound plus phosphonylide. Then hydrolysis of vinylic ether H plus bar H2O converted to a carbonyl compound. So an important question, a coupled question. What type of reaction in the first step? This is a conjugated polyene and under thermal condition, definitely electrocyclization reaction. A conjugated polyene under thermal condition, definitely that is an electrocyclization reaction. Okay, so 1, 2, 3, 4, 5, 6 carbon, 6 pi electrons are involved in the cyclization process. So this is the type of cyclization. A new sigma bond is formed between first and the sixth carbon. So a 6-membered ring is formed. This is the first carbon and the sixth carbon. Here an OCH3 is present. Okay, in the first carbon a CH3 is present. Between 2, 3, 4, 5, 6, 2 and 3 a pi bond is formed. Between 4 and 5 a new pi bond is formed. Okay, so that is the product formed in the first step, electrocyclization process. Then one more step is given. In the next step, H plus bar H2O. What is the reaction? H plus bar H2O. H plus bar H2O. Here a vinylic ether is present. Carbon-carbon double bond followed by OR, which is a vinylic ether. Under hydrolysis, this lone pair on oxygen will attack the H plus. So in the next step that you will get CH3 as such, here O H plus CH3, and in the next step what happens? In the next step H2O, what type of attack? SN2 attack, backside attack. So you will get an enol is obtained. Ring, pi bond, OH, CH3, and enol is obtained. That enol will undergo tautomerism. Here extended conjugation is possible. So tautomerism, this bond here, this one here, this one there. Extended conjugation is possible, and finally you will get the product a 6-membered ring. Here double bond O, here a pi bond. The CH2 minus catch up the H plus to form a stable compound. Here a CH3 is also present. CH3. So the stable product, which is an alpha beta unsaturated carbonyl compound. So electrocyclization followed by hydrolysis of vinylic ether. So two important coupled questions. Wittig reaction with the electrocyclization with the hydrolysis of vinylic ether. So very important.